All right, so we'll start with our unit on magnetism by addressing the question, what is magnetism? That's a creative way to start, isn't it? Um, but magnetism's weird, so it requires this. So why are magnets difficult to kind of get a handle on? I think a big part of it is this image at the right. It looks like a toy to us, right? We sort of fiddle with it. Oh look, you pick up some iron filings. You can move around the filings and make a little picture, um, and that seems about it. And we sort of think, well, they're not that prevalent, and magnetism doesn't matter that much, but everything you do on a computer depends on magnetism. Storing information is magnetic, um, and the visual displays have magnetism involved with them. There's all sorts of magnetic things going on in electronics. So it's really crucial to what we're doing. Um, on a kind of everyday basis. And then on top of that, it's just sort of physically mystifying, right? It's a parlor trick, right? You pull the magnet and look, I can move that thing without touching it. And we don't sort of think, well, that really happens all the time, right? It's electrostatic force. We can't see that. We can't see gravity. And yet there's something that seems foreign to us about magnetism. So what is it? Um, well, it turns out that magnetism and electricity are not really all that separate. They are considered part of the electromagnetic force, and we'll talk about electromagnetic waves later in the course. We think of those as being one force, the electromagnetic force, rather than the electrostatic force on one hand and a magnetic force on the other. A quick definition of magnetic force gives some sense of how it works. Well, not really how it works, but what causes it. And that is that a magnetic force occurs whenever a charge is in motion. That's a really broad definition, right? I mean, how often is a charge in motion? Like all the time, everywhere, right? So there's magnetic fields that are being created all the time by the movement of charge through the world, whether that's a current or a moving charged particle. There's some sort of something's happening in the magnetic field when that happens. Why does this happen? Why does a moving charge create a magnetic force? Um, this is where my explanations fail. It just does, right? And it's just one of those fundamental forces. We don't, in some ways, we can try to ask what causes gravity, but it doesn't occur to us to ask that. When we try to ask why two masses are attracted to each other, which is what gravity is, or two electric charges are attracted to each other, um, which is what electrostatic force is. Um, it seems more natural that those things happen. But with magnetic force, it's hard to understand why a moving charge would create a force. But we can compare those three fundamental forces and say to ourselves, okay, a mass creates a gravitational field, a charge creates an electrical field, and a moving charge creates a magnetic field. That's the key link between those things. Like those other fields, gravitational and electric field, magnetic fields is a vector field. So if we look at this here, we can draw force lines, right? Just like our electromagnetic or our electrical fields, okay? And we can draw them in terms of vectors. They have a direction and they have a magnitude. Each magnet, every magnetized object, and so when we say magnet, that can be a molecule, it can be one of those, nice red and white iron bars that we see. But every magnet has a north and a south pole. There's no such thing as a magnetic monopole that just has one pole. It always has a north and a south. If I cut this in half, I've got two magnets with one with a north, both with north and south. Um, so you can't get rid of that dualness of that here. And they are attracted to each other by their poles. A magnetic pole will always be repelled by a like pole and always be attracted by an unlike pole. So then that way it's similar to when we talk about electric charges. So a north pole is attracted to a south, but if I try to push two magnets together like this, the north poles are going to repel and the south poles are going to repel each other. That's why when you turn a magnet, uh, as you're trying to put it together, one side, if you turn it one way, it's going to pull together. You turn it a little bit and it's going to give that cool little bouncy feel to it because those two magnets are repelling each other. And so that's your magnet basics. We'll get into the complications as we go on.